It's said that for giving humanity the gift of fire, Prometheus was condemned by the gods to eternal torture. I wonder, do you think he thought it was worth it? There are many different ways to simulate fire in computer graphics, and, as such, every game will have a slightly different implementation. For the aspiring graphics programmer, it can be difficult to know where to start. However, there is one game in particular which stands out as a pioneer of 3D graphics in video games. Thanks to the magic of modern emulation, we now have access to the actual textures Nintendo used to create the fire effect for Ocarina of Time. But without the shader program to use them, these textures are all but useless, right? Not quite. Using in-game footage in conjunction with the original textures, it is possible, even probable, to reverse engineer the exact same shader used by Nintendo's programmers all those years ago. Let us start with the most important aspect of a fire shader, its transparency. It's a trivial matter to turn an object transparent with Unity's default surface shaders. Not so with a custom unlit shader. These tags tell Unity that it needs to render this shader after all of the solid objects in our scene, since of course the color of a transparent material depends on what's behind it. Similarly, we need to tell this shader not to write to the Z buffer, also known as the depth buffer. The depth buffer can be used to determine if one object is being blocked by another. If a transparent object writes to the depth buffer, it may stop other objects from being rendered behind it. We will also turn off culling, which isn't necessary for transparency, but will stop our quad from disappearing when we look at its backside. Finally, we need to choose how our transparent object will blend with the objects behind it. This is similar to how you would choose to merge two layers in your image editor of choice. We will use the most basic blend mode, which will do a simple mix of the foreground and background colors, using alpha as the parameter. A nice feature of these textures is that the alpha value is embedded in the texture itself, represented by a black color. Of course, we would like to set the flame to whatever color we desire. This can be easily accomplished by multiplying the texture output by a tint color. Now we need to figure out how to incorporate both textures at once. We can add a second texture slot to our shader, but we still need to figure out how to combine it with the first. We could try to naively add them together, but this obviously isn't right. Let's try multiplying them instead. Now, the dark spots of the first texture cancel out the bright spots of the second, and vice versa. Next, we need to animate the noise pattern. Let us simply subtract time from the UV coordinates of the second texture. It might seem counterintuitive that subtracting time causes the texture to move upwards. You'll often hear this explained away by the observation that whatever you do to UV coordinates will always work in reverse, but I find that to be a poor explanation of what's happening. Instead, imagine a single spot on our plane, somewhere near the top. By default, this point will have a large UV.Y component, so it will naturally grab a point high up on the texture. If we repeatedly subtract values from this UV.Y coordinate, it will of course point to lower and lower spots on the texture. Do this smoothly and continuously, and the texture will appear to slide right up the plane. Now, I don't like how dark our texture has become after we multiplied the two textures together. I will compensate for this by adding a flat value to the value of our noise texture. This fills out our flame and makes it look much more realistic. There is one final thing we must do to fully emulate Ocarina of Time's fire. You might not know this, but there is a subtle toon shading effect applied to the fire in certain areas of the game. This was most likely done to simulate overwhelmingly bright light and give the fire a subtle bloom effect. As an aspiring graphics programmer, anytime you hear the phrase toon shading, I want you to immediately think of the step function. As its name implies, a step function is a mathematical function whose output immediately steps from 0 to 1 when the input passes a certain trigger point. We can use this in the context of shader programming to have the brightness of a pixel jump from one value to another when it passes a certain threshold, in place of a more realistic lighting gradient. This technique is so effective at mimicking the solid blocks of color used in cartoon drawings that it has forever earned the moniker toon shading. I'm going to use the length of our color value as a stand-in for brightness, and set the threshold point to 1. Now, the spots brighter than 1 will return white, and the spots darker than 1 will return black. Obviously, we would like to return our original color, so we can use the step function as the parameter of a linear mix. Now when the step function returns 0, the pixel will retain the value of the original color. When it returns 1, the pixel will take the value of our new, bright tint. Ideally, we should be able to come up with our own textures instead of using the ones created by Nintendo. Luckily, it is not very difficult to create textures like this yourself. In GIMP, create a new 64 by 128 image with a black background, and use a circular brush to draw a large rounded line in the center of the texture. Next, create a new layer, fill it with a white to black gradient, and then blend it with the first layer using the Darken Only filter. Finally, use a black pencil brush and slash at the first layer to carve out the shape of a flame. You can then merge everything together and use the Color to Alpha filter to create transparency. Optionally, you can use the swizzles in Unity's texture import to set the alpha to any of the color channels, and vice versa. The noise texture will of course use GIMP's built-in noise functions. Create an image of the same size, and use the solid noise filter to add turbulent FBM noise. Create a new layer, add more solid noise with a different scale and offset, this time without checking turbulent. You're free to choose any blend mode you like for these two layers, but I found Dodge to work quite well. Finally, add another new layer and use the sinus filter to create a sinuous pattern. If we set the layer blend to darken only, we will get some much needed contrast in our texture. You may once again merge the layers and convert the color to alpha, and don't forget to tile the texture seamlessly to avoid a noticeable seam in the animation. I hope you've enjoyed this tutorial on recreating the flame graphics from Ocarina of Time. You should feel proud of yourself for creating a lightweight fire effect without having to deal with any cumbersome shader nodes or particle effects. You will find the code used in this video in the GitHub repository linked in the description. I hope you'll join me in the future as we continue our journey of recreating retro-style shaders from video games. Thank you for watching, and I'll see you in the next video.